welcome back to Calculus. Today we are starting chapter 4 with section 4.1, extreme values of functions. So basically we're going to be looking for biggest and smallest values for functions as we go through here. So a couple of things that we just kind of need to know, and then we'll jump in and look at how we start finding these. An absolute or global maximum, and an absolute or global minimum. Those are exactly what they sound like. They are either the biggest or the smallest value that a function takes on its domain D. Okay, and this happens for maximum at x equals c if f of x is less than or equal to f of c for all x and d. So that y value that you get out if you plug in c is the biggest, right? Everything else is smaller or equal to it. And turn it around for min, f of x would have to be greater than or equal to f of c for all x in the domain. Now, as we'll see, we're going to be able to restrict these to some intervals instead of like everything sometimes, and we'll talk about that in a couple of minutes. But I do have a little graph here, and it kind of illustrates a difference between two things that we'll work with, an absolute and a local. In this case, I have minimums on here. Okay, so an absolute minimum would be the absolute smallest value that comes out of the function on the domain. In this case, I'm using all real numbers for my domain. A local minimum, it's kind of a minimum, right? I mean, right here, it's the smallest value, but that one's smaller. So we're going to be able to work with both of those. We're going to be able to find both of those. Importantly, for the local minimum, if we just restricted the domain, and we'll see this in a second, to just a piece of the number line, all of a sudden, in this piece of the number line, that local minimum turns into an absolute minimum because it is the smallest value here. So I'll get some more stuff on the board and we'll talk about it, but this is the basic idea. We're going to be hunting and searching for these biggest and smallest values. All right, so I have a couple of theorems to go through here, and then we'll actually start practicing finding these. It's kind of straightforward, and it's going to... Anyway, so let's get into it. I have a theorem. If f is continuous on a closed interval ab, so we have a piece of our number line, then f attains both an absolute max and min in ab. So our goal is going to be to find those biggest and smallest values in that interval. Now, importantly, those, we'll get to that. All right, the other theorem, and then I'll keep talking. If f has a local max or min value at an interior point x equals c, and if f prime is defined at c, then the derivative is 0. So a couple of things here. First, an interior point for an interval is a point that's in between the endpoints. Okay, so we're not looking at the endpoints. Interior points are everything in between. I think that seems reasonable. But importantly, if you have this local max or min, it's going to be where a derivative is 0. Okay, and that's going to be really important. So basically what we're going to end up doing here is we're going to do a couple of things. We're going to take the derivative of the function. We're going to set it equal to 0 and solve, and that will give us what are called critical points. So this c here, c is a critical point. And you want to know that phrase. Okay? Critical point is any point where the derivative is 0. But we're going to be checking places where the derivative is 0, and then we're also going to have to check the ends of our interval. So to find absolute maxes and mins on an interval, we're gonna take the derivative. I'll say it again. We'll take the derivative, where we'll set it equal to 0 and solve. Wherever the derivative is 0, we're going to plug that x value in and see what we get in the original function. We're also going to plug in the endpoints, and then we just choose which one's biggest and which one's smallest. Let's do an example. All right, so here's my example. And this process is going to work whatever the function is. Some of them will be easier to solve than others. Some of them will be easier to differentiate than others, but here's my example. Find absolute max and min values for f of x equal to 3x to the fourth plus 5 on the interval from -2 to 3. Now, you can see the answer down here because I ran out of room and had to shove it down there, but let's go take a look at all the work that I did. So we have our interval, we have our function. So I start by taking the derivative of my function. This is a continuous function, it's differentiable everywhere, so we can go ahead and just take that derivative. The derivative, I drop the 4, 4 times 3 gives me the 12, I have x cubed, the 5 just drops out. So then I set my derivative equal to 0. So when I do that, and if I solve it, I get x equals to 0, and that is my critical point. And so then all we have to do to find the absolute maximum and minimum values is go back to the original function, because we want the original function, we want to know where it is biggest and smallest on this interval, and I plug in the two endpoints, and in between I have my critical point. That's the only three places that this function can possibly have an absolute have a maximum or a minimum value on this interval. Okay, remember the picture that we drew. Those maximums and minimums, they happen at the bottom or top of that curve or at the endpoints. So we plug them in. F of -2, if you work it out, gives you 53. Again, plugging it in back here. F of 0 is 5, and F of 3 is 248. All that's left, say that we have an absolute min of 5, because that's our smallest one, at x equals 0. And we have an absolute max of 248 at x is equal to 3. So that left endpoint didn't do anything for us. We're looking for the biggest and the smallest. And that's really what we're doing here in this section. So there you go. Nice little short video. Have a great day.